Hi everyone, I'm so excited. You are ready for your robotics automation challenge. We are going to have some fun. So let's take a look at your mission. Your driving question is, how can you design a remotely controlled robot to remove hazardous waste from a disaster site? So back in 2011, this actually happened. There unfortunately was a huge earthquake off the coast of Japan, which triggered a tsunami. This tsunami in turn triggered several catastrophic events, one of which was the degradation of the Fukushima Daiichi nuclear power plant in Okuma, Japan. So this was a real-world scenario where humans could not be exposed for long periods of time due to the hazardous radiation. So let's take a look at solving this problem. To do this, we're going to evaluate the design process. You're going to be going through this process step by step. Let's start at the top with ask. What do you need to know to solve this problem? So you're going to explore solutions. You can do some research within your group. Then each member of your group is going to come up with their own idea and solution and sketch it out. When your group is ready to move forward, you're going to select one design and you're going to model it. That's right, we're building robots. Once you do that, you're going to have to evaluate that robot and test it, see if it works. Notice these arrows go in both directions, so it will be common and you should expect to do some redesign work. When it's all said and done, your group will be presenting to the class and you will have to talk about the decisions that you made and why. So your lesson objectives are to explain what happens at each step of the design process. You'll state questions that engineers may ask when gathering information about a situation people want to change. You'll identify inputs and outputs within a robotic system and brainstorm and evaluate existing solutions to a design problem. We are going to have some fun. So let's review what you need to know to get this done. The design process, which we just talked about, how to use a decision matrix, we'll talk about that next, and how to remove those connector pins. So the decision matrix is a tool for you to use in your group so you can all decide which is the best robot you would like to use. So you can put down idea number 1, idea number 2, idea number 3 and 4 down on one column, and across the top, write down the criteria your group thinks is important to solve this problem. It could be robot maneuverability, sensors, and the claw or scooping device that's going to help you remove the hazardous waste. Once every member in your group presents, you're going to put a check mark next to each criteria that was met. Afterwards, count up those check marks, and the robot with the most check marks is probably the one you're going to want to move forward with. You can also do a blend of ideas. That's part of your group to decide. So let's talk next about those connector pins. Keep in mind that we're using the VexIQ robotic parts to build our robots, and these pins are made to be secure, fitting, so that it can maintain the integrity of whatever you build. So naturally, they are a little bit hard to remove. So here we have the connector pins, and those 1x1 pins are especially hard for me to remove. And we have our graham cracker piece here, which is a building component, but I call it the graham cracker. And so there's very little area in which to grasp, but you got this. You can remove it by flipping the graham cracker piece over, and then you can stick your thumb underneath and kind of pop that pin out a little bit. So when you do stuff like this, you need to make sure you put a hand or a cover on the other side so that pin doesn't go flying across the room or in someone's eye. Another idea that works a little bit better for me is to use that silver shaft and to approach it from the underside again and poke that out. So you can also use other building components that have a corner or a beveled edge, and you just do the same thing. Poke it out from the underside and pull it out. Keep in mind you're going to be doing this a lot as you construct and deconstruct your robots to solve the problem. So the sensor motors present a different situation because you can't approach the pin from the underside. But actually, there are some things you could do. Obvious is use your thumbnail to wedge in between the pin and the sensor motor. That's a little hard for me to do. Here's a clever approach. Take something like a beam piece and snap it on the top, and then you're just going to roll it backwards so it gently pulls the connector pin out. From there, you already know how to remove the connector pin. You can use one of the ways we just discussed. So just gently roll it back and you've got this. Easy peasy. Let's move on. So when you come into the classroom, your immediate responsibilities are going to be group communication. And by that, class, you are going to need to listen. All right? I want you to have a flexible mindset and listen to all the options involved. You're going to document in your engineer notebook. That's where your sketch will be.
Bud Davis, can you please move your car? Thank you.
That was nice. So in your sketchbook or engineer notebook, you're going to put your sketch, and you're also going to record your jobs that you had that day. So things like builder and whatever those jobs may have been. Sorry, discombobulated. You'll also want to put in any measurements. This is going to be really important when you have to go back and deconstruct and reevaluate. This is also important because this is how I'm going to assess some of the things you're doing and see how you're using class time. One thing I really want you to do also is document with the camera. This is going to come in handy for your presentations, so don't forget, and I'll help remind you. So let's do a quick overview of our project. You're going to document constantly. You're going to start out with a group discussion, sketch out your ideas, use a decision matrix to come up with a solution, and model it by building your robot and bringing it to fruition. Then you're going to have to test and reevaluate. Once we do that, we can all practice driving. That's right, each team member is going to be a driver. When we do that, we can also start planning for our challenge. It's going to be awesome, guys. We're going to design a floor plan of the nuclear plant yard, and they're going to have a few elements in it. One is we're going to start out with a parking spot where our robot is going to be and where it's going to begin its work from. And then we're going to have a safe area for the hazardous blocks. We're also going to have a water source. So it's next to the ocean. We can't cross into that ocean because we don't want to contaminate it. We're going to do that by these pens over here. Oh. Okay, so we're going to do it with these red pens. I mean a red pen here, and okay. And because our sensors can't cross into any zone marked red. So there's a little tip for you. You're going to be using that red sensor. All right, so the other element is the hazardous nuclear waste. They're going to be represented by those little blocks. Such a klutz. We're going to use these red blocks here. All of these blocks actually, so you're going to want to make sure you measure these and get the dimensions so your robot can clasp, shovel, push this out of the way. That is going to represent our hazardous waste. Okay, when you do this, you're going to have 2 minutes. Each driver will have 2 minutes to see how many nuclear hazardous waste blocks they can move into the safe zone area. It is going to be awesome and fun, and then we're going to end with our presentations. Okay, I cannot wait, and don't worry, I'll be there to help you every step of the way. Well, let's define that. I'm going to be wearing my oven mitts, so this is how I can help you. I can pat you on the back, give you that high five, point, and go, how can we solve that problem? That's about the extent of it. Everything else is going to be up to you, and I know you can do it. So tell me, what do you think? Do you have any thoughts, any questions? Leave your comments on the Flipgrid below. Make sure you sign into that Flipgrid so I know you watched this lesson. Awesome!